Hi everybody, we're going to be looking at graphing y equals tan of x today with some transformations. So as you can see, I've got my y equals tan x already graphed here on Desmos. You can see it has that point at the origin, tangent of 0 is 0, and then as we head towards pi over 2, we kind of curve up towards being very, very steep, and we approach infinity as we get close to pi over 2. Pi over 2 is an asymptote. I've marked it here with the green line. Notice it's just never going to touch it. It's going to go off towards infinity as it gets close to it on this side, and then it's going to come in down towards negative infinity on the other side of it. Same thing happening at negative pi over 2. I don't have all the asymptotes marked on here, but hopefully you kind of get the idea. Four things we can do to the tangent graph, and you can do them all to the cotangent graph as well, but I'm just going to show you tangent today. One is we can shift it upward, a vertical shift, and this is just like when we did vertical shift for sine and cosine. Adding is going to shift us up, subtracting would shift us down. You can see I've got a +1 here, and this is what that would look like. It's just up 1 unit from where it was previously. The asymptotes are still the same, but we have shifted up 1. What was once 0, 0, now 0, 1. What was once pi over 4 comma 1, now pi over 4 comma 2. Everything is getting shifted up by 1 unit. So pretty simple concept. Had I subtracted, it would have shifted down. Next thing we can do is amplitude. You'll notice I have a 2 out here in front. This is going to have the effect of kind of taking all of those y values and making them twice as high. When we did sine and cosine, that caused us to go to higher maxes and lower mins, but we don't really have maxes and mins on the tan graph because we go to infinity and to negative infinity. So the amplitude here is just going to make us look steeper. So I'll take a look at that one. This blue graph is y equals 2 times the tan of x. So, 2 times 0 is still 0. At this point, it didn't make any difference. But if you look at pi over 4 comma 1, became pi over 4 comma 2. So we still have the same curve. We're still getting the same asymptotes. We're repeating, just as frequently. But it's just a bit steeper. It doesn't look as curvy when you get it kind of with the amplitude there. It just makes it look steeper and a little straighter. So that's your amplitude. You can also shift to the side, a phase shift or horizontal shift by adding or subtracting within the parenthesis. So here I'm going to show you tan of x plus pi over 2. And remember, in the parenthesis, shifting with a plus sign causes us actually to go left, and with a minus sign causing us to go right. So what's going to happen here is a left shift by pi over 2 units. So what I'm expecting, and I'm going to remove these asymptotes for a minute, is say this point that's 0, 0, I think it's going to show up over here, pi over 2 units to the left. Let's take a look and see. Yep, sure enough. So adding that pi over 2 caused me to go from here at 0, 0 to here at negative pi over 2 comma 0. Now, in this particular case, I actually could have had a minus here, and it would have ended up looking the same because this graph repeats every pi unit. So shifting to the right by pi over 2 actually would have given me the same thing. So it doesn't really matter if it's a plus or minus if you have pi over 2. If you had some other value, might make a difference. But in this case, that plus pi over 2 is shifting me left. Okay, last one, we can change the period or the frequency of our function. So you can see this thing is repeating every so often. You get a point like this one that is effectively the same as this one. It's the same as this one. And every pi units, we seem to see another point that basically looks the same. Well, when we multiply in the parenthesis like this, it's just going to make these happen more often, more frequently if we put a number greater than 1 in here. So here's y equals tan of 2x. Notice the function is just happening twice as often. So there are 2 purple curves for each one red one. And each purple curve ends up having to look a little steeper because it's happening, within a shorter space in terms of the x's, within a shorter domain, I guess you could say. So you get more frequent lines with a big number in there. And if you put a fraction in there, like say you put 1/3 x, well, now I'm seeing, wider and less frequent purple lines. So that's what's going to happen if you put those in there. You get a different period or different frequency. So all these graphs can be done with cotan of x as well. It'll basically work the same, except everything is going to look like it's kind of sloping down the hill instead of up the hill. All right, thanks for watching.